All right, so this is another gas law problem. It says calculate the pressure, okay, in atmospheres of 8 grams. So they didn't give me the moles here. They gave me the grams of helium gas in a 10-liter container. So liters tell me it's the volume at 27 degrees Celsius. And again, I'm going to add, your book adds 273.15, but looking at the key I gave you, I usually add just 273. So 300. That's what I'm going to do so we can get close numbers. All right, so... All right, in this problem, when I'm looking at what they gave me, they want me to find pressure. I've given the mass and the volume and the temperature. So they're talking about the 4 properties that describe a gas. Now, many of the laws, Boyle's, Charles, Gay-Lussac's, Avogadro's, all of these laws involve a change in conditions. So they're the ones that have the 1 and the 2. And so like they'll increase the temperature and say, hey, what's the new volume or whatever. And this problem only gives me one set of conditions. And so we do have a gas law that deals with the 4 properties in one set of conditions, and it is the ideal gas law. So it's PV equals nRT. Now, N is in moles, so I'm going to have to convert the this to moles using the molar mass, which is something we worked on in chapter 7. So to go from grams to moles, I would look up, it says it's helium. And if you have a periodic table nearby, helium is 4 grams per mole. And so we'll put the 4 on the bottom so that the grams cancel. And so 8 divided by 4, so we have 2 moles. All right, so I don't know P, that's going to be left as a P, times the volume, which is 10 liters. That equals N, which is 2 moles, and then R. Now R, don't forget it. It is a gas constant, and it does have to be included in the equation. I do give it to you. The one I give it to you has the following units: liters, atmospheres, moles, and Kelvin, which is an important point. When you're solving, you want to make sure that the values for the units and the properties that you have match R. So like we do have liters, we do have Kelvin, and we do have moles. And so our pressure is going to come out in atmospheres. Okay, so let's plug in R times 0.0 over mole Kelvin times T, which is 300. Now, if you're trying to get rid of units now, K goes away. Moles go away. Now, here again, we could be different. You may multiply this whole side right here. All it is numbers, so you can simplify by multiplying. I tend to rearrange first. So I would look on this side, and I'd say, okay, I'm going to divide by 10 so that P is left. So then I would write, whoops, sorry, I didn't mean to do that. I would write P equals, then I have everything on the top, 2, I've gotten rid of the units, times 0.0821 liter atmospheres times 300 divided by 10. So I took the 10 that was, oops, sorry, I used the wrong feature. The 10 that was here, and I moved it and divided it to the other side. So now P equals, liters cancel. My only unit is atmospheres. So in my calculator, I say 2 times 0.0821 times 300. That's all on the numerator. Then divide it by 10. And I get to 2 significant figures, I guess, because that's what the mass and then the moles were. I get 4.9 atmospheres. Now, again, because we all are a little bit different in how we approach our math, I want you to go to this part where I just outlined in blue. At that point, we had plugged everything in. Then I want you to practice, how would I rearrange this? Would I simplify first? What do I divide? Because it doesn't matter if you do the same steps that I do, in the same order. It's always hard, again, I said, because we all come from a little bit different place of how we learned our math. So I want you to look at that and then reinforce your math skills by practicing how you would rearrange it. What comes naturally? What have you already learned? All right, so 4.9.